Hello, everyone. I said, hello, everyone. Hello, perfect. Good afternoon, everyone. And I'm super excited to talk to you today about how you can build your own Copilot using Azure AI Studio. I was supposed to talk today with my friend and colleague Sjoukje Zaal, but unfortunately she is sick. So you have to bear with me today trying to explain you all the goodness that we have to offer in Azure AI Studio. So my name is Henk Boelman, I'm a senior cloud advocate at Microsoft, and I'm focusing on the AI topic, talking about Azure AI, of course. So today, I want to talk to you about Azure AI Studio, the new studio that we launched at Microsoft Ignite. And Azure AI Studio is kind of the whole solution that you can build your AI systems, from data all the way up to running your models into production. And if you look at the Copilot stack that we have at Microsoft, you can see it actually fits right in the middle of it. So it is the tool to orchestrate your AI workloads. So Azure AI Studio unifies various AI services for a seamless experience, catering to diverse models, diverse data sources. It has the OpenAI foundation models and other open source AI models from our partners. And it helps you to build this AI responsible with the safety tools that are available in that studio. And finally, it supports the complete lifecycle from prototyping to run it at scale in production. So, enough talking. So let me show you how that actually looks like, our new studio. So when we switch to the demo machine, please. Perfect. Then voila, here is Azure AI Studio. So everything starts with a project. So I've already created a few projects, I've been busy, but if you want to create a new project, you just click Create New Project. So let's go to the project, Henk's AI Project. And first of all, let's dive into the settings, because we can configure a lot here. So, and if the internet is working today, we will actually see those settings here. There we go, it's loading. Perfect. So when we go to the Azure AI Studio, we first look at all the settings that we have. We have a place where we can manage all our connections to our AI resources, to our search indexes, to our data sources. We have API endpoints that we can call, and the keys we can manage here. We manage our compute instances, which we need to run PromptFlow and other machine learning tools. We have our runtimes, which we can share so that everyone is using exactly the same versions of PyTorch, of Python, and so on. So we can all manage these runtimes here. And the good thing is we can have project members. So you can share it with your colleagues and set permission levels, what your colleagues can and cannot do. And of course, you can see how much it all costs here. Another important thing in the studio is deployments. Under deployments, you can manage all the different types of models you want to have and the models you need. So here you can see I've deployed DALL-E 3, GTP 3.5 Turbo with the latest updates. I have GPT-4 Turbo here that goes under the name 11.6, 11.06 Preview if you're looking for it in Azure. And it is only available in Sweden at the moment. So if you want to try it at home, look there. I have my GPT-4 Vision Turbo here. So here are all your models. You can just create a new one and pick the model that you want. And it will deploy for you here, and you pay per token use. And those models you can use, for instance, in the playground. So if we go to the playground, we can actually ask a few questions here. So here I have a question like, how much does the trail walker hiking shoes cost? So if I would ask that, then the model will respond back very fast. I'm sorry, but I don't know. I don't have real-time information, or the website, it's not available. I'm a model, and I can't look up real-time information. But what we can do is we can quickly connect it to our own data sources. by the button, add your own data. So I've already set it up here in the next step. I've connected to my products v2 database that contains a lot of markdown files. And in those markdown files are my product information. So if I want to ask the same question, it should look that up and tell me the Trailwalker hiking shoes are priced at $110. And the cool thing is that it is referencing where it is found that information, and that is actually here in the document in my search index. And I know this goes very fast, but in the end, I will kind of explain how everything ties together and build our own Copilot here on stage. So another fun thing is, because we're using these models, it is automatically multi-language. So last week, I was in Greece playing with OpenAI, and I was like, let me see if it works in the Greek language. So I translated the question, how much does the Trailwalker hiking shoes cost, into Greek. And if I would have put it there, if I can copy and paste, yes, I can. If I would ask it here now in Greek, it will actually return the same information in English here, and you can also make it respond back in the local language if you use, for instance, GPT-4. The final thing that I want to show you and emphasize is the system prompt. A very important tool in building your large language models, because the system prompt can really influence how your model responds back to you. You can put in safety guardrails, you can put in the tone of the model. So I made a very small example here, and I say, you are an AI assistant, you always respond in a rhyme, you're friendly and funny. And I want to emphasize also that specifying the tone of your model is very important, because these models kind of mimic what is coming in. So if you are to use this in a chatbot and your customer is angry, we would not want that our chatbot responds back angry to our customer, because the only thing the models do is predict the next most likely token, the next likely word. And that word probably is a continuation of the tone that the model already tone of the input that the model received. So I have it here, you're friendly and funny. We can dive in, we can do a whole session about system messages, but this is what I want to give you for this session. So I'm now going to ask, what can you tell me about The Hague? And we'll come back with a delightful rhyme about the city of The Hague. That is a Dutch delight. And it rhymes. So with just like three lines of text in the system message, I'm able to kind of influence how the model responds to me. And one thing you also want is to be able to test your model. And you don't want to sit and type all these sentences all the time and see what it is there. You want something automated for that. So luckily, we have that built in Azure AI Studio. So we have manual evaluations. You can specify the input and the expected output, run it against the model and see if it scores correctly, yes or no. But you can also import a complete test set and run it against that test set. And that is what I have done here. I have used it with the system prompt, the AI assistant. I've connected my own data, and then I run all these test inputs. How much does the Trailwalker hiking shoe cost? Expected 110, so this is correct, so it gets a thumb up. And so I've been able to score my model and see if it is doing what it is supposed to do. So let's go back to the slides. So the next thing I want to take a look at is data. We have seen this sentence, data is the fuel that powers AI already in the keynote. But I sometimes like to say, garbage in is also garbage out. And that is especially true with models. If you don't feed your model clean, good data, your model is going to produce exactly the same crap or good. So I see it a lot of time with our customers that they come up with poorly formatted data, with unclean data, and that leads to horrible outcomes of the model, and all your effort is kind of for nothing if you don't start with good data. So Azure AI Studio can help you get the data in a nice way from all kind of different data sources. You can start with having it in a blob storage. You can connect it with Fabric. You can connect it, even upload files locally for your experiments. It takes both structured and unstructured data. And here I want to emphasize that our goal here is, with Azure AI Studio, is to make it easier for all of you to get your data ready to train your models on it and create business value here. So one thing that is at the heart of all of this is the concept of vector search and using vectors for data representation. So vectors are mathematical representations that allow systems to easily compare data for relevance and similarity. However, vectors vary in creation and in quality. And we're super proud that Azure AI Search, which formerly was known as Azure Cognitive Search, and before that as Azure Search, it supports vectors. And that is now generally available since Ignite a few weeks ago. And the cool thing about Azure AI Search is that it just doesn't only do vector search. It actually brings together vectors, semantic search, and classical keyword search. And that helps to get you the most relevant answers to your questions. So we talk about this as vector hybrid search. And it actually has dramatically a positive impact on the search results that you're getting out of the search index. So Azure AI Studio offers 3 search options. Pure vector search. But vector search really excels in understanding user intent and relationships between words, but struggles with finding the exact matches. While keyword search is ideal for finding specific items like product names, email addresses, and phone numbers. And hybrid search combines these two so that you will get the right results. So let's dive in a little bit deeper in how that works, bringing our own data to Azure AI Studio. So we will switch back to the demo. Perfect. Okay, Azure AI Studio. So everything starts with adding your data. You can manage your data under data, of course, and then you can click add new data sources. It can come from all kind of different places here. For me, I've just uploaded a bunch of files. And what I've uploaded is the data set, I have a lot of data sets here, is Contoso products with weather data. These are the markdown files that contains all my product information. For the ones that did not see it, the product information is about a retail store that sells outdoor like tents and hiking shoes and jackets. And it contains warranty information, reviews, frequently asked questions. But what I did here is I added an extra file with the weather data and climate data from Seattle, because I want it not just to be a search engine that can find products, but can also make relations between different things, like the weather in Seattle and what kind of jackets or shoes you would recommend for that. So I've uploaded all that data in Markdown. The next thing what you can do is you can go to indexes, create an index from it. So you click New Index, you select your data source, and it will kick off in the background a pipeline for you, chunking the data nicely. And so what it does, it normally makes chunks of data. It doesn't factorize the whole document. It makes chunks of it. And that's one of the most difficult questions at the moment. What do you chunk and how do you chunk it? But Azure AI Studio does that automatically for you, so that is great. If you want to see how Azure AI Studio does it, here's the pipeline, and you can open the job details and see how it is done in the background by Azure Machine Learning. Okay, so now we have an index. We can actually connect that index to the Azure AI chat session here, the assistant, the playground. You do that by clicking Add Data, select the data source, select the fields you want, and then you can start asking questions. So now I'm asking the question here, what products are suitable for the Seattle climate? And I'm using GPT-4 Turbo for that. So we're going to see if it will answer us today. So first it starts, based on the retrieved documents, the following products are suitable for the Seattle climate, which is cool, wet winters, and mild relative dry summers. So it retrieved that from the document. Then it is doing some recommendations about the products that might fit there, and it tells us where it has found the information, and we see that it has found the information in our Seattle document. So this is really to illustrate that you can have a big, diverse set of data in there, and that the system can make relations between your files and reason over that data. Okay, let's go back to the slides. And talk a little bit about the foundation models that we have to offer. So with the high data, we need data as an input. But the foundation models have that critical factor that, like, if you don't have good data, the foundation model is not performing very right. So I hope I've showed you that you can kind of do that in Azure AI Studio. So Azure AI Studio offers models from OpenAI, such as GPT-4, GPT-4 Vision, 3.5, and the new turbos, but it also offers other open source models, like the Llama models and from our other partners. So for us here, the key is to ensure that you have choice of model, because one model can be very good in a specific thing, like GPT-4 is super good, but you don't need GPT-4 to achieve all your goals. You can have a simpler, smaller model, for instance, that also runs a little bit cheaper. And if you build a production system, most likely that you combine a set of models to do specific tasks for you. So what we offer is choice in models for you. So at Ignite, we announced GPT-4 Turbo, GPT-4 Turbo with Vision, and DALL-E 3. And the cool thing about GPT-4 Turbo is that it is faster and cheaper. So you can use that very high qualitative model in new scenarios. And DALL-E 3 really creates really nice images, and you can try it for free in the Bing Image Creator if you want to play around with DALL-E 3. So the upcoming trend is kind of going towards multimodality. So traditional models are kind of text-based, text in, text out. But with GPT-4 Turbo with Vision, it can reason over images. So you can give it videos, you can give it images, and you can ask questions about it. And so the power goes beyond language. Now one model can combine the visual world with the text world and incorporate those visual elements into the conversation. One other thing that I really want to highlight is that your data remains your data. Your data is within your tenant. We don't touch it. We don't use it. We definitely don't use it to train our new foundation models. So your data is safe in Azure. Another thing we announced at Microsoft Ignite is that you can fine-tune now GPT 3.5 Turbo and GPT-4, and GPT-4 Turbo is currently in private preview for fine-tuning. But I want to take a little moment to talk about RAG vs fine-tuning. So RAG stands for Retrieval Augmented Generation. And that allows us to incorporate data directly into the system prompt without retraining the model. So we add knowledge kind of on the go. So RAG is super efficient for that. Very cost efficient because it is relatively quick and you only need like your data in an index. And that is kind of an inexpensive way of doing that. So our internal test shows that RAG is very effective for adding additional knowledge to your AI experience. So fine-tuning models requires a bunch of extra compute, and fine-tuning is really useful when you want to modify the tone or the output format of the model, not for adding additional knowledge. So in the Azure AI Studio, we have the model catalog. All the models there. From there, you can deploy the models, you can fine-tune the models, and there is a traditional infrastructure-based approach for that. So you click, you spin up a VM, we deploy it, we run it, and you can use that model. But that is great. But we're also offering now a new way where you can deploy some of the models as a service, where we take care of all the infrastructure for you. So I'm super excited to announce that we have Models as a Service. So Models as a Service works that you can right-click, deploy the same way as you did with your Azure OpenAI models. Like you click Add New Model, say Deploy, and you only pay for the tokens you use. And the same thing goes for fine-tuning. We also have fine-tuning as a service now. The first thing we have done is apply that to Llama 2, but more models, of course, will follow. Another question you might always have is like, which model do I choose, and how do these models perform against different data sets? So we made it easy for you. We introduced a new model benchmarking system, where you can compare the different models using different data sets, and then you can, based on that, pick the model you want. And later on, we will also offer that you can run your own benchmarks in there. So let's go back to a demo, where I can show you benchmarking and these cool model as a service features. So first, model benchmarking, you just go to Azure AI Studio, you click on benchmarks, and then you can specify the task that you want the metrics on, and you can choose the models you want to benchmark against each other. And if you don't select anything, it will do everything. You click on compare, it will load my project. You click again, compare, and if we see it right, we should here see how accurate the models are. We see the accuracy, we see the different data sets, and we see the different models here. So if we want to go for fine-tuning, we can go to the model catalog. Here are the Llama 2 models. I can click on View Models. I can click on this one, the 2.7 billion parameters for text generation. I will see all the specifications, some documentation. On the right side, I can test it, and I will get a button, perfect, that says fine-tune. So I can click on fine-tune, I can select the project I want to run it in, it will check if I have my marketplace in there, and I can set subscribe and fine-tune. I've already fine-tuned some of these models. Now, if you fine-tune your model, you see this one took me 1.5 hours to fine-tune. I've used my training data set and my validation data set here, and all the metrics about the fine-tuning are available here in the portal. And when I'm happy with that model, I can just deploy that as pay-as-you-go, which is later available under my deployments. So here is my fine-tuned model. If I don't want to fine-tune my model and just want to use the Llama model, I can go back to Explore, to the model catalog, go to the Llama model here and say deploy. I can still choose to deploy it as a real-time endpoint where I'm responsible for my own infrastructure, but I can also here go as pay-as-you-go so that I only pay for the tokens I'm using, and I can test that here. So now, these models that you have deployed, oops, oh, that is one too far, that's for later. I can go to, I can go to build, I can go to deployments, I can click on the deployment, and I can say open in playground. And now that model is available here to test out and play. So if I say my name is Julian and I like to, Llama 2 can complete that with my own serverless instance. And here we see that it has done that. So we were talking about DALL-E. DALL-E 3 is there to create images. So I've done a few here, photorealistic image of the hake. I don't know, it's very accurate, but it looks really cool. And here I had a photorealistic image of some cute raccoons on a planet. So we can do something like a painting in the style of Rembrandt of Den Haag. Generate. It takes a while for these images to generate, but they are great quality, and you can also define how large you want to have these models returned, if it is like 1024 by 1024, or if you want to have them smaller. And everything you do, what you see me doing here in the interface, can be done in code. So you can call everything, all these models in code. And here we see Den Haag in Rembrandt style. Perfect. Next, the last thing that I want to show you is GPT-4 with vision, because I think that is like really super cool. So these prompts take a long time. Sometimes you have to wait 10 to 20 seconds for the answer to come back. So I've run a few things here. So I uploaded the image with a paperclip here, and I asked, is there a landmark on this image? And the response was, yes, this image depicts a landmark. It's the famous Angkor Wat temple located in Cambodia. Super cool that it can just kind of see that. Then I asked, like, plan a one-day trip to the city on this image. It perfectly does that. The city in the image is New York, known for its iconic skyline. The midday, the afternoon, it seems very busy. It's not my kind of trip, but it's a trip. And then, starting to combine models is where the real power is. So I enabled the enhancements here. I enabled the vision enhancement that is using our Florence model in the background. So I asked kind of, what is on this photo? It returned like what was on this photo and a modern cityscape. I can click on that word, and now it kind of highlights that exactly in the image. It took a very good look at the image. And the funny thing I wanted to highlight here, and it looks like there's being undergoing some construction. And I think it is mentioning this building here. So you see, combining these models really gives you the power and even more insights about these images, like the buildings here. And the model can do way, way, way more. So I encourage all of you to deploy one of these models in Sweden and play with it when you come back home. Okay, let's go back to the slides. So I want to talk a little bit about safe and responsible AI. So we at Microsoft have these principles in place for a long, long time now, of how we approach AI and how we think about safe and responsible AI. So think of things like fairness, reliability, safety, privacy, and security. But the thing is, it's not just principles. These principles infuse in our engineering processes, in the way how we build these kind of systems. Everything from how we source data until how we train our models. And I'm super excited that we have now these safety tools we use internally now available for you to use in your AI solutions. So we use them internally and externally for content moderation. And these services are capable of identifying hate speech, sexual content, and jailbreak attempts. So content safety is designed to help maintain the safe digital environment. So this works with the Azure OpenAI models. It is built into your deployments. It filters your input. It also filters the output of your model. And that is not all. It is available as an API. So you can use that system in your own websites. If you have a moderation tool, if you have comments on your website, if you have incoming images you want to scan, you can use this system by simply calling an API. So now let's talk about getting this stuff in production. How does it support the full development lifecycle? And that is an incredible key thing. How do we move from the prototyping phase all the way to having this responsible and scalable in production? Because it goes further than just calling an API and walking away. There is quite a bit of engineering needed, from shaping the prompt to the orchestration, to the APIs that we're calling, on how to scale it and how to deploy it. So you need a complete way of doing that. And at Microsoft, we have a feature within Azure Studio that is called Prompt Flow, which is generally available today. It is our tool for prompt orchestration, for evaluation, and prompt engineering. It is deeply integrated in Azure AI Studio, and it is also in our Azure Machine Learning product. So most of the things you have seen, like importing your data, adding your own data, under the hood, that are all prompt flows running, automatically created by Azure AI Studio. And you can kind of open these prompt flows in Visual Studio Online, or even on your own desktop in Visual Studio Code, because to use prompt flow, it's open source. You don't need to run it in Azure AI Studio. And finally, you want to monitor how your large language models are doing at scale and how they're doing in production. So when your model is deployed in production, we can kind of monitor it of how it is doing. And we can warn you if these models going out of tune, because these models are not super deterministic. So evaluation is at the heart of this, how you actually make sure that your application is doing the right thing. So now, I want to close off with building a Copilot from scratch here in Azure AI Studio. Okay, so let's go to the overview. Here is my project. So what I've already done is I've uploaded my data. We're going to use our products v2 dataset, which just contains the information about the products. I've created an index from that. So if I click on the index, we can kind of go to the job details. It will open Azure Machine Learning Studio, and it will show us the complete flow as how it has chunked our data and how it actually has kind of injected that into a vector database in the behind. So this is all backed by Azure AI Search. So what this does is it breaks up your documents, it chunks your documents, creates vectors from it, and puts that in a vector store in Azure AI Search, which you can just go to and see how it has been done. And I think we can actually kind of do that if we go to portal.azure.com. If I log in, no to vector, so thank you for that. We're going to our Azure AI Search. I'm using today, where is my Azure AI Search? Sorry, this is not AI Search. This is AI Search. So I'm using my HBO Search 2 database. I have my indexes, and we can find the products v2 index here. We can click search, and we can see what is in here. Here's the product information. Here's the vector. This vector is generated by the text ADA model. And the size of the vector is 1,536 dimensions. So it is a lot of floats that are in this database. So all the records are here. And my records are only 20 documents. And there are 61 documents in here. And that illustrates that it kind of chopped the document in 3 pieces for us. So now that I have my index, I can start building my own prompt flow. Because what I'm going to create is, from scratch, a chatbot that you can interact with your own data, and which you later on can evaluate to see if the responses that the model the RAG gives are grounded in the data that it retrieved from the vector store. So what we do is we create a new one. I'm going to have a chat flow, and I'm going to call it Ignite Netherlands. We say create. It will create here. It creates a very basic chat flow. I can select here my Azure OpenAI instance. I'm selecting the GPT-4 model. Here are my parameters, my temperature, my maximum amount of tokens. I can also call functions in here if I want, so everything is there. And for our prompt creation, we use Jinja 2 files, which has the system message, which has the user message, assistant, and user. Kind of all these different roles, but then in a simple text file. Can click off chat, and you can say hello, and we can see if our prompt flow is actually running. Wait a little bit, because it has to wake up. It's being deployed in the background, and it says, hello, how can you assist you today? And a good thing is that it tells us how many tokens it used, because that is also one thing you want to monitor, that you use just enough tokens to give the right answer, but not use too much, so your Azure bill is like way, way, way too high. Okay, so we have it here. So the next thing we have to do is create an embedding from our input, because we are going to compare vectors against vectors, so we're going to do a vector search. So the first thing we need to do is create an embedding from our incoming question. So we call it create embedding. We click add. We select our connection. We select our embedding model. So this is the OpenAI embedding model, but you can basically create your own embeddings models, use open source embedding models, it doesn't matter, as long as the embedding that you're creating here matches the embedding you've created with your, from the data that is in your Azure AI search. So we take the input is a question, and now we see our flow is becoming kind of a flow here. The next thing we have to do is look it up in our database. We do a vector database lookup. Say lookup in database, click add. I'm selecting the connection to my Azure AI search. The index name is products v2. We don't have any search filters. We don't have any parameters yet. The content is in our content field, and the vector is in our content vector field. Here you can specify how many results you want to have back from your search engine. So now it's just giving me the top 3 back, but you can also say 5 or 10. But the more results you get back, the longer your prompt gets, the more tokens you're using. So I'm leaving it at 3, and I'm going to use the vector that came back from my embedding. So now our flow is getting a little bit of shape. We create an embedding, and we look it up in the database. So now we need a little bit of customization here, because I want to shape kind of the data that comes from the vector database and not inject it directly into the prompt. So I'm creating a new Python step here. I call it format results. I'm clicking add, and now I can just type Python here, and it can run it. And in your environment, you can specify which packages you need, and so on. So you can basically go wild in this input field here. So I've already written a piece of Python here that kind of formats the data a little bit nicer. So it says the content, it gives me the file path, the source where it came from, and the content, the text from the search result. I have to click validate. It will automatically scan for the variables and creates nice input boxes here in front of me. So I'm just going to give it the docs from the search engine. That is the output from the database. Here we see that. And I'm saying you can keep everything between the 3,500 tokens, please. And now it is there. So the final thing I have to do is to construct my system of my prompt for the model. So we go back to the chat here. And I've already created that system prompt because nobody likes to see me do that live. So I'm pasting it in. So I'm starting with, so this is a very, very basic prompt. I want to emphasize that you need to add your safety rules, your jailbreak rules, and all the other things in here. But then it would have been like this big piece of text. So what I'm showing here is you are an AI system that helps answer questions, giving a specific context and conversation history. You will be giving the context and the chat history, and then ask questions about that context and chat history. And please also add citations to where you found that data. The first user message is all the retrieved documents from the search. I'm putting that in there. Then I'm looping through the chat history. And then finally, the user question. So I validate and parse the input again, so I can inject that result from my Python format. And now we're starting to have a pretty cool prompt flow here. So let's test it and see if I made any typos. So I'm going to ask, how much do Trailwaker hiking shoes cost? I'm sending that. Starts building my prompt flow. The cool thing about prompt flow is that you can see all the outputs from all the individual steps. So you can, if it doesn't work, you can actually debug where it is coming from. And I've typed everything in one time right, so I'm super happy. So, and it tells me the Trailwaker hiking shoes are $110, and the source is in this document. And now, of course, I can use some scripting to make it links and so on. So now that is done, I can start testing it. So I can click evaluation. I can say I want to build in evaluation. We call it test, questions and answering pairs, next. What do you want to evaluate? Ignite Netherlands, next. You select your metrics, and you select your GPT assistants, because your GPT will help evaluating your RAG. Next, you can select a data set, map your values there. I have a testing data set here. Where is it? Here, where my question is in, and the ground truth. And now, because I did not do that here, if I would return as an output here also the documents, I know I forgot one, it is available to evaluate in evaluations. So I need here the formatted results also, and if I now click evaluations, we can compare like the inputs if the answer is grounded in the search results. So I have already run that because that runs around 10 minutes. So if you go to evaluation, yeah, let's save it. If you go to evaluations, we can kind of see that here. It will load. So here you see I've done a few evaluations against the other RAG. I can click here, and I see if my model is grounded, so that the result is visible in the answer. If it is relevant, some questions are not very relevant. If it is a coherence experience, and if the answer is fluent. And here we see how every single prompt scored. So this is how you can do that. But this is also what you want to know about when real people are using your system. So I can deploy that prompt flow by going to prompt flow, go to Ignite Netherlands, click here on this deployment button. I can specify it here. I can make my instances scale so that it is automatically load balanced. I can do A/B deployments. I can have 50% traffic going to one flow, 50% traffic going to another flow. And when I do that, I can connect one of these monitors that measures for groundedness to those deployments. So I'm going to my Ignite, my Contosa products demo. This is one of these deployments. I can actually test it here, just say hello. It tells me how I can consume it. Wake up. Perfect, it is here. I can have some information about how to consume it, how to call it. And finally, I have my monitoring here about how my model is doing, and I can set alarms on that. So if the groundedness for the last 10 requests is below 3, please send me an email, and then I can investigate that. So that was building a RAG in less than 10 minutes, all the way from your data on a local file system, all the way up to running in production, monitored in a scalable endpoint. So if we go back to the slides, I have one more. That is thank you, and I hope you enjoy your day.